Assalamu alaikum students. Today I am going to repeat the lesson very quickly because that day you could not write the notes and somebody could not read the lesson because of the coverage problems. Okay, now motion. What is the motion? I gave the definition for the motion that day, and the motion is actually the changing of position with the sign of an object. Then here, motion in a straight line, that is our lesson, because this motion can be categorized according to the direction and other characteristics of the motion. But here we are going to learn only the straight line, motion in a straight line only. Then okay, the distance and displacement. What are these terms? Okay, distance is a concept familiar to you. When you go from home to school, you have to travel a certain distance. Sometimes there can be several paths you could use to travel between home and school. Some of them could be shorter and some longer. Here, a figure shows the path, several paths a child could take to travel from a point A to B. There are three paths P, Q, R. Now you can observe, are the length of these paths equal? No. The length of the path is known as the distance. That is the case. The second definition we have to note, the length of the path is the distance. So here the length of path P is not equal to Q and that is not equal to R. So the length of the path vary, that is depending on the path. So the distance vary with the path. But the short distance has shown in the dotted line. The shortest distance is here 160 meters. What is the other difference between this shortest distance and the other path? Yeah, the PQR. Along the P, the direction of the ball changes with the time. In the QR also the same manner. The direction of motion is varying with the time. But here, in the shortest distance, the direction always direct to A to B to the east. So there is a definite direction in the shortest distance. So this shortest distance given a special name, that is the displacement. Okay, then let's write some notes for this. Here I have given what is the motion changing of position of the object with the time is known as motion. What is distance? Length of the path in a motion is known as the distance. Distance depends on the path. Distance depends on the starting and the end point. Distance not depend on the direction. Okay. Next, displacement. The change of position that occur from one point to another point in a particular direction is called displacement. Displacement is the shortest distance between two points. Displacement depends on both direction and points of starting and end. Displacement is a vector quantity because when expressing the distance, we are not consider about the direction, but when expressing the displacement, we have to mention the direction. So this displacement has both magnitude and the direction. Quantities like this are known as vector quantities. So displacement is also a vector quantity. Okay, now let's see another example for distance and displacement. Here, 200-meter running track used in a track event is shown below. Here, this is the playground. We know this red line is the track used to running event. Here, I have shown the west, north, that direction, and the starting point. The motion is starting from A to B, that is the running track. So the path is shown by the arrowhead. Here, when starting the race, move towards the north, then bending towards the west. So the direction changing along the path. There's no a particular direction in this path. So along this path, this child has to run 200 meters. So he is running 200 meters. That is his distance. Distance means the length of the path. But the difference between the starting point and the ending point is shown by this dotted line. That is the shortest distance. That is called the displacement. When we express the distance, we can say that is 200 meters. But when expressing the displacement, we cannot say only the magnitude of the displacement. This displacement can be expressed in the following manner. 160 meter in the direction 70 degree from north to west. Here, north to west. This is the direction. So this is the way expressing the displacement. Okay, now can do this exercise. A child starts from a point A and walks 40 meters to the east until he reaches another point B, and from B he walks 30 meters to the north to reach the point C. A 40 meters, B 30 meters, C. This black line is his path. Then, what is the total distance traversed by the child? Yeah, the total distance is the length of the path, that is 40 meter plus 30 meter. So, this is the way we express the. Okay, then what is the displacement? Displacement is the shortest path, that is in a particular direction. So here the shortest distance is the 50 meter. Am I correct? No. I have to express the direction too. Then what is the direction? North to east. This is the way expressing the displacement. Okay. Next to that, the speed we did that day. Again, I repeat, what is the speed? Speed is the rate at which a given distance is traveled. That is, speed is equal to distance by time. Then, other words, speed is the distance traveled in a unit time. These things we did that day. Again, an example we are going to do for this, the time and the distance given in the table. According to this data, distance crossed by the object during the first second. The first second is 3. Can you see the board now? Can you see the screen now clearly? The first second, 3 minus 0, that is the distance 3 meter. The second, 6 minus 3, that is 3. So similarly, the distance traversed during each of the third, fourth, fifth and sixth seconds is also 3 meter. That is, the object has traversed 3 meter during each 1 second time interval. Understand? Therefore, in this case, we can say that the object has moved at a uniform constant speed or constant speed. So speed can be expressed distance by time. Since the time is given in the second and the distance is in meters, the speed has the unit ms minus 1. M by S. Accordingly, the above object has a speed of 3 meters second minus 1. Okay. Now go to the example 2. Here distance traversed has given and the time also has given. Now the distance traversed by this object is 3 meter in per second. The first second 3 meter. What is the distance traversed in the second? 5 minus 3, that is 2, isn't it? And 9 minus 5, then that is 4, isn't it? Okay, like that. Therefore, the distance traversed by this object during each interval of 1 second is same or not same? Answer please. Can you answer, any of you? Same. Same. Oh, not same. Very quickly you want to calculate. Not same. Not same. Good. That is, this object has not traveled with a uniform speed, isn't it? Okay. In these instances where an object does not travel with a uniform speed, it is useful to calculate the mean speed of the object during a given time interval. The mean speed of an object can be calculated by dividing the total distance traveled by the corresponding time interval. Mean speed is also known as the average speed. Okay, so how to calculate the mean speed? Total distance divided by the total time. This is the revision. That's why quickly I move this. The total distance covered by this object during 6 seconds is 18 meters. Therefore, the average distance covered during a second, 18 meters by 6 seconds. Then it should be 3 meters. Understand? Yes, good. Now children, that is the mean speed or average speed of the object. We got it? Okay, so now next to this 2.3 is velocity. Velocity is different from speed. Why? Can any of you answer this question? Are these velocity and speed same? What is the difference? No, why? What is the difference? Speed is velocity is vector quantity. Why it is vector and scalar? Very good. Like this you want to answer, children. Why speed is scalar? Speed is rate of distance. Isn't it? Distance is measured without any direction. Isn't it? But velocity is rate of displacement. Displacement means length of the path in a particular direction. Isn't it? So it mentioned the direction too. So velocity is differ from the speed. more this detail. Because we calculate the speed in terms of distance, we do not consider the direction when we calculate the speed. Therefore, it must be clear to you by now that the speed is a scalar quantity. The velocity, however, is defined as the rate of change of displacement. Therefore, it is a vector quantity that has both a magnitude and a direction. Okay. The velocity of an object can be obtained by dividing its displacement by time. An example here given a table. Displacement 0, 3, 6, 9, 12. Time 1, 2, 3, 4. Since the increase, here the increase in the displacement of the body during each second is 3. How to get it? The first second, the displacement is 3. For the second, the displacement, the final displacement is 6. But with the time duration interval, 1 second interval, 3 to 6, the difference is 3, isn't it? Again, 6 to 3, the displacement difference is 3. 9 to 12, that is also difference is 3. Then the displacement difference during the same time interval also equal. Right. So, since the increase in the displacement of the body during each second is 3 meter, the motion has taken place at a constant or uniform velocity. Okay, that is, for a body moving at a constant velocity, the displacement after a certain time interval can be obtained by multiplying the velocity by the relevant time interval. This one also did that. Displacement is velocity into time when it is the constant velocity. Okay, now go to the mean velocity. Now observe the table. What has happened to the displacement? 0 to 4, 4 to 7. 0 to 4, 4 to 7. 4 to 7, what is the gap between 4 to 7? What is the difference between 4 to 7? What is the displacement at the first second? Velocity. How to get it? Revision. Very quickly revise this. Huh? Here, 4 to 7, difference is 3. 7 to 9, difference is 2. 9 to 12, difference is 3. So, 3, 2, 3, like that. That is not uniform, isn't it? So, the displacement is of this object 4 meter in the first second, 3 meter in the second, and the 2 meter in the third second, etc. As the displacement is not the same in the every second, the velocity of the object is not uniform. In such occasions, we can calculate the mean velocity. Okay, children. According to this table, the displacement is, what is the final displacement? 12. Then the total time is 4. This is the way get the mean velocity. That day we did this. Okay. Another example, the variation of the displacement measured with the respect to the starting point of a child riding a bicycle on a straight path during each 1 second time interval is shown in the below. 1, 2, 3, 4, 10 seconds. Displacement 2, 4, 6, 8, 8, 8, 8, 8, 4, 0. What kind of motion has child undergone during the first 4 seconds? This is the revision. Then first 4 seconds, 1, 2, 3, 4. What has happened? 2, 4, 6, 8. Increasing uniformly, isn't it? These things we did, and the answers also has given in the book. So I don't repeat again and again. Go to the next point, acceleration. What is acceleration?
The rate of change of velocity is known as the acceleration. That is the change in velocity per unit time is acceleration. So acceleration is change of velocity by time, that is given A. Acceleration is A is equal to V by T. Now, here also given, according to the above data, the velocity of the body has changed from 0 ms minus 1 to 12 ms minus 1, increasing, isn't it? According to the data, velocity 0 to 12, it is increasing. Isn't it? So, the time taken to increase is 6 seconds. Change in the velocity is velocity at the end, final velocity. Isn't it? This is final velocity. That is final. Understand? This is final velocity. Then what is this? Initial velocity. Okay, then the change is final minus initial. Okay. When we divide the above velocity change, that is 12 ms minus 1 by the time duration for this change, then we get the rate of change of velocity. Now children, according to the above data, what is the initial velocity? That is 0. Then 12 minus 0 is 12 is the velocity change. Time duration is 6. 12 by 6 is 2. We can get it here done. Okay. That is done here. Huh? Okay. When a body has an acceleration of 2 ms minus 2, it means that its velocity changes by 2 ms minus 1 during each second. If the acceleration has a positive value, it implies that the velocity is increasing. If the value is positive, velocity is increasing. A negative acceleration means a decrease in the velocity. Suppose that a body moving in a straight line had an initial velocity of 12 ms minus 1, which later varied with time as shown in the following table. 12 to 0, 12, 9, 6, 3, 0. Then that is decreasing. You can see that through the table. Here, the velocity has decreased. The acceleration of this body can be calculated like this. Change of velocity, how to get the change? Final minus initial. Here, which is the final? 0. 0. 0 is the final. Then, this 12 is the initial. Okay, here we have obtained a negative value. Here children, you can see this is a negative value, isn't it? Here, this is a negative value. Here we have got a negative value, isn't it? Here we have obtained a negative value for the acceleration. It means that the velocity has decreased by 3 ms minus 1 each second. These things that day also we learned. Again, I want to repeat this. Okay, that day you could not write the notes clearly. These are the notes. Inshallah, you can copy these notes. You can get a print. Otherwise, you can get copy with the recording, inshallah. Okay, children. Then, if the velocity is decreasing, the acceleration takes a negative value. A negative acceleration is known as what? What is known as the negative acceleration? Very good. Now, all my children have got the point, I think. Okay. If a body has an acceleration of minus ms minus 2, acceleration of minus, it means that the body has a deceleration. I will give you practice questions, then again you can repeat it, okay? If the velocity of a body either increase or decrease by the same amount of every second, that the body is said to have a uniform acceleration or deceleration. In order to find the displacement of a body moving at a uniform acceleration, we should find the mean velocity of the body and multiply it by the corresponding time. So, how to get the displacement, isn't it? When giving this, displacement is mean velocity into time, isn't it? Displacement is what? Velocity into time. When it is an acceleration, the displacement is mean velocity into time. This case that day I explained you. Here I got this previous lines. Here I give a mark. Here I put a box here. What is here? Displacement is velocity into time. When it is a constant velocity, isn't it? When there is a constant velocity, then only we get this. Okay, when it is constant velocity, then we get displacement is velocity into time. Again, I go to the next page. Children, repeat this. Displacement is mean velocity into time. Here I have marked it by the box. There also I marked by the box. These are two different instances. Remember this please when doing the questions. Okay. Now the mean velocity, what is the mean velocity? Initial velocity plus final velocity by the time. Isn't it? Okay, let's do some example to verify this. A body start from rest is subjected to uniform acceleration for 6 seconds, after which is acquires a velocity of 12 ms minus. What is the initial velocity? Please tell me. Yes, start from rest. So how to get that? The initial velocity is 0. Isn't it? If it is rest, it means that is 0, isn't it? Okay. It's subjected to a uniform acceleration for 6 seconds, after which it acquires the 12 ms minus, that is the final velocity. Isn't it? Now what has happened to the velocity? Is it increased or decreased? Increased. Very good. This girl, very nicely you have understood. What about others children? What is the displacement of the body? Here, what is the question? Children, the link is going to again disconnect. Then again you want to join. What is the displacement of the body? Mean velocity into time. Okay. Shamha. M.R. Shamha. Are you? Were you the girl that day I talked with you when you were at the end of the last row? Now I can remember your face. Okay. Join again.